So you want to use Azure Storage for your Terraform backend, but you're not sure what the best settings are. That's what we'll talk about in this episode. What's up, everybody? Welcome to Terraform Tuesdays. I'm Ned Bellavance, nedinthecloud.com, and today we're going to talk about the way that you should set up your Azure Storage account to work with the Terraform backend. That is, you're storing your state data from your Terraform config in an Azure Storage account. The Azure Storage account is one of the supported backends, but a question I often get is, what are the best practices and settings that I should configure to properly secure things? We'll walk through an example, but also talk through some of the security options that exist for a storage account and how you might go about configuring them depending on what scenario you're dealing with. Now, before we get into that, two quick things I want to mention. One, did you know I have a Terraform certification guide? I totally do. And if you're thinking about sitting the Terraform Associate exam, you should definitely check it out. It's got all of the objectives covered, as well as being updated for the latest version of the exam. So you can check out the link down in the description. The second thing I want to mention is, do you know I have a podcast called Day 2 Cloud? I do, and we covered the challenges of being in an operations role in a cloudy world. And each episode, we delve into a particular aspect of being an operational engineer or a DevOps engineer, whatever you want to call it, someone who's deeply involved in operations and dealing with the challenges that come from a cloud framework. So if that sounds interesting to you, I'll also include a link down in the description. Now let's get on to the main topic. Once you've started using Terraform for a while, you quickly realize, hey, I need to store this state data somewhere. And there are many different backends available. One of those backends is Azure Storage. Now, the way it actually stores the data in Azure Storage is it makes use of the blob portion of Azure Storage. So we're not dealing with files, we're not dealing with tables or queues, we're just dealing with the blob portion of things. And what it actually does is it writes a JSON file as a blob to Azure Storage, because that's essentially what Terraform State is. It's a JSON file. And it also supports workspaces by appending a string to the key name that you use for that blob for each additional workspace that you add when you're using the same state data backend. Now, if you're curious about workspaces and why they're bad, I have a whole video about that as well. You can check that out when you have a moment, but let's talk about the actual configuration of the Azure Storage account. Now, there's a few primary things to keep in mind when you're dealing with state data. One, it may include sensitive information. So you want to protect that state data. You want to restrict access to it to only those who truly need read access and only those who truly need write access. So if a process needs to update the state data, obviously it needs write access. And if a process simply wants to access that state data as part of getting configuration information for itself, then it will need read access. Everybody else should not have any access to that state data. So that's one way in which you need to secure it from a permissions perspective. And we can do that through a combination of different mechanisms that exist in Azure Storage. The other component is encryption. You want to encrypt that data at rest and in transit. And again, Azure Storage has a number of options when it comes to encryption. Let's cover the access portion of it first with the different authentication formats that exist for Azure Storage. Azure Storage has a number of different ways that you can successfully authenticate and gain access. So I thought I would cover those very briefly. Now, at a very high level, when you create a storage account, you also generate storage keys. And those storage keys serve two purposes. You can use the storage keys to have full access to that storage account. So those are like the God mode, the God credentials of that storage account. They can do basically anything. But they're also used to sign tokens. They're called Shared Access Signature Tokens, or SAS tokens for short. And they're signed using the private portion of the storage key. And then the public half of the storage key can be used to validate that token, to verify that it is in fact valid and was signed by that key. Now, if you're using SaaS tokens, you have a lot of control over what that SaaS token can do. You can set restrictions on what level of access it has. Can it write? Can it read? You can set it at what tier in your storage account it has access to, down to the container or the individual blob. You can set a time limit, so it's only able to be used for the next 90 minutes, let's say. And you can also set restrictions on where the request is coming from. You can say only accept requests from these public or private IP address ranges. So a lot of power there, but you do need to use the storage keys to sign those SaaS tokens. And those storage keys are kind of dangerous because they can do anything. So what's the alternative for authentication? Well, there is Azure AD or Entra ID integration. You can access the storage account directly using a user or a service principal that exists in Entra ID. Additionally, if it has permissions, that Entra ID user or service principal can sign SaaS tokens and hand those tokens out for access, which means if you're using Entra ID-based authentication, you can disable the storage key. You no longer need it if you're just using blob services. There are some other caveats here that I don't want to go down that rabbit hole, but if you're just using blob storage, which is what we're doing, you can disable the storage key so it's not even in use. And I think that's probably a pretty good idea if you can rely on Entra ID. So that covers all the different authentication versions. What's the best way of issuing authentication credentials? Well, I'd say the best way is to use an Entra ID service principal. And the actual authentication mechanism could be OIDC, or it could be a temporary credential that gets issued, or it could be a temporary certificate that gets issued. And if you're in automation context, you can actually use a service principal in Entra ID to sign SaaS tokens you give out to your worker nodes. Then those SaaS tokens can be good for only 90 minutes or 2 hours, depending on how long you think that Terraform run will last. And after that, the tokens expire. So that would be my recommendation from an authentication perspective. Now let's talk about recommendations for encryption. All Azure storage accounts have encryption in transit turned on by default, and you can check it so that that is required. Only HTTPS traffic will be allowed. So that covers us from a in-transit encryption perspective. Now, also, all storage accounts are encrypted by default using a Microsoft managed encryption key. So you don't have to do anything to enable that encryption. It's already enabled. If you want more control over that process, there's 2 additional layers you can add. The first one is a customer managed key. So you can provide your own key material to do the encryption of that data. And now you're the one who's managing that key instead of Microsoft. Some industries and regulations require that level. If you don't require it, letting Microsoft manage the key is probably the better play, but I'll leave that up to an individual decision. The other thing you can do is double encryption using infrastructure-based encryption. So not only does the data get encrypted in the storage account, but when it hits the actual infrastructure where it's stored, it is encrypted a second time on disk. Now that might seem like overkill, and in most cases it certainly is. But if you have that specific requirement, you can double encrypt your data for additional security. That way, if one of the 2 keys is compromised, whether it's the infrastructure key or the storage key, you still can't fully decrypt the data because you need both keys to undo both pieces of the encryption. So that covers encryption. What about network access? How do we deal with that? By default, Azure storage accounts are publicly accessible in the sense that they get a public address from which they can be accessed. But you can restrict that level of access based off of source public IP address. So that's one level of restriction you can add for network access. If you know that all of your Terraform workloads are going to be launched from a particular range of public IP addresses, then you can configure your storage accounts to only accept traffic from those public IP addresses, which is fantastic. You kind of lock things down. However, that traffic is still traversing the internet. So if that's of concern to you and you want to further lock things down, you can turn off public access entirely and instead expose the storage account using a private link endpoint in one of your VNets. When you do that, now the storage account is only accessible from that private endpoint in that virtual network, which means if you're going to be running Terraform processes, you need to route that traffic to the VNet across an internal network. That certainly makes things more complex, but if you're going for the absolute highest level of security, it might not be a bad idea, especially if you're running your Terraform workloads on worker nodes that are inside of Azure to begin with. Now, you can leverage that internal access to expose that private endpoint just to those worker nodes. That's a more complex setup. We're not going to get into that, but it is certainly an option if you're concerned about network access. Now, one thing I want to bring up is in terms of permissions and access, how do you configure the actual access if you're using Entra ID and Azure RBAC? Because that's how you set permissions on the storage account. Well, you can create your own custom roles that have very specific allowed permissions, or you can use one of the predefined permission roles that are out there. Now, if you aren't that concerned about it, you can go ahead and use one of the predefined roles. There's a storage data blob contributor role, I believe that's what it's called. And if you select that, that gives contributor access, so read and write access. And you can set that at the container level or the storage account level. If you're going to be putting multiple containers that contain Terraform state data in a single storage account, but you need to assign permissions individually, you can do that by using the RBAC permission model at the container level. If you would like to further lock down the permissions, Azure also offers what's called Attribute-Based Access Control, or ABAC. If you add ABAC to the custom role assignment, you can add additional conditions on top of it that further restrict the access within that storage account and container. So you can actually lock the permissions on a role assignment down to a particular key or path, as opposed to doing it at the full container level. So if you want the absolute most restrictive permissions, which you probably do, you can accomplish that with ABAC. So with all of this in mind, let's look at a Terraform configuration that will deploy a storage account with a lot of these principles applied. Okay, so here is my example configuration in VS Code. If you're looking for this code, you can always find it on my Terraform Tuesday repository. And we're going to be making use of the Azure RM provider as well as the Azure AD provider, because we're going to create a service principal to assign the role to and set some specific conditions on it. So let's go over what's in the configuration so we can kind of get a feeling for what's going on. Now, to start off with, I'm going to generate a random string that I can use for naming the storage account, because storage account names have to be globally unique. I'll create a resource group, naturally, and then a storage account. Let's look at some of the settings that are being configured here. Account tier is standard. That's fine. Account kind is storage v2, and I'd recommend this, especially if you want to put these additional permissions requirements and some other settings for retention and protection of that state data. That's one thing that we didn't really cover, is the fact that state data is pretty important, so you don't want to lose it, and you want to enhance the durability of that state data and make sure that you can recover it in the case of an incident, either your fault or Microsoft's fault. Which brings us to the next setting, account replication type. I would recommend GRS for this. That means that a copy of your data will be replicated to another geographically separate but related region. So if that region fails, you retain access to the state data. We want to force all traffic to use HTTPS, so we'll enable HTTPS traffic only. We'll set the minimum TLS version to 1_2 or 1.2. That's the highest level that's available today in the storage account. Shared access key enabled, we're going to set that to false. And what that does is disable those storage account keys that we didn't want to use in the first place. We're using Entra ID authentication instead of using this storage account key. Default to OAuth authentication is true. That has to do with how authentication is handled at the portal level. So it will default to using Entra ID instead of the storage account key. And I am not turning on infrastructure encryption, but if you feel like you need it, you could change this setting. Under the blob properties are some specific settings that have to do with versioning being enabled, which I would definitely recommend. If something goes wrong, you may want to look at previous versions of state to see what has changed historically in that state data. You can't just copy that old version and restore it and use it. There's a little more to it than that, but if you want to get a historical reference of what's been happening with your storage account, definitely recommend turning that on, as well as change feed enabled, which tracks what changes have happened to a blob over time. And I set the retention to 90 days, but you should set it to whatever makes sense for your organization. Last access time enabled also logs, hey, when's the last time somebody updated that and who made the update? Again, important stuff that you might want to know about what's happening with your state data. The delete retention policy just sets how long that a deleted blob will be kept around in a soft delete state so you can recover it, as well as container delete retention policy keeps a container in soft delete. So if someone goes in and tries to delete all of your state data, you'll have a way to recover it from a soft delete state. That is also, it's pretty important. For the SaaS policy, we're creating a default policy for the generation of SaaS tokens where they'll only be good for 2 hours. So the default amount for any SaaS token is 2 hours. You can adjust this accordingly, and when it expires, the expiration of the SaaS token will be logged. These are all good things you might want to have enabled. Now, within the actual container that we create for the storage account, the only important thing, and really the only setting you can set, is setting the container access type to private. That's what it is by default, but you know what? I'm going to make it private just to make sure. And then I'm going to create a second storage container here called tfnope. And this is just to demonstrate that if I change the path, my attribute-based access control won't allow me to access the tfnope container, even though I have a role that does allow me to write to any container within the storage account. The attribute-based access controls will restrict me on that. Speaking of which, now we get into a custom role. So we're going to create a custom role. Now, if you look at the documentation, you'll see that storage blob data contributor role, or whatever it's called, is the recommendation from HashiCorp. But I would like to create a more restrictive role. And so this one has 2 actions that are allowed. One is to read containers, and the other one is to generate a user delegation key. That allows it to create the SaaS token to interact with the storage account. And then for data actions, the only data actions that are allowed in here are blobs read, blobs write, and to add a new blob. That's the creation permission. Those are all the permissions that are allowed, and we'll see how this is assigned to a service principal in a moment, which that's the next thing we're going to do, is simply create a service principal that we can associate this role with. Within the association, the role assignment, that's where you get to set the additional attribute-based custom permissions. So we're going to hook up the service principal we just created along with the custom role we just created. And then we have this additional condition argument, which is pulling in a template file. And we're passing it the container name as well as the state path within that file. And that's going to define what container it has access to, as well as what key inside that container it has access to. And we're using condition version 2. So let's take a look at that condition.tpl file. This is incredibly hard to read. Basically, what it's doing is the first one is taking a look to see if what we're trying to access equals the container name. Are we trying to access the container? If it's not that specific container that's passed as the container name, then you don't get access to it. The other thing it's checking is to make sure that we are performing a read, write, or add, and that operation is happening on the state path that we specify. So the state path, or the key for our Terraform state, in this case, I'm passing it the value taco wagon. So in our condition, that will render to the path inside the container is taco wagon /something. That's where I'm going to write my state data. Beyond that path inside that container, I don't have access to anything else with this custom role and the assignment to the service principal. So that's everything in here. And then at the end, I have a bunch of outputs of the information so that you can make use of it. So what does that configuration look like? I have an example configuration that leverages this storage account. Let's take a look at that. In the storage test directory, I have an example configuration, and in the Terraform block, I have my backend set as AzureRM. Now, very important here, we are using Azure AD authentication, aka Entra ID authentication. So this has to be set to true. And since I know that, I feel comfortable hard coding that into the backend block. But the rest of the configuration is going to be configured at runtime using the -backend config flag with the Terraform init argument. What's in that information? Well, for that, we can look in this backend.tf_backend file I created. Now, there's nothing special about that file extension. It just tells me this is the backend config, and I can also add it to my git ignore so I don't accidentally commit it. In here, I have the storage account name, the container name, which I know is TF state. That's what I granted permissions on in that attribute-based access control, as well as the key, which is taco wagon terraform.tf state. If it's not that key, if I try to use a different path, I won't have access as well. And then I have my authentication information. Now, in a production type scenario, you would want to submit this authentication information in another way, whether that's through a SaaS token or some sort of integrated OIDC authentication. For testing purposes, I just hard-coded it right into this backend file. So if we bring up the terminal and I run a Terraform init and I point it at this file, it's going to initialize my backend and it should successfully connect to that storage account and configure it. Okay, great. It says I successfully configured it. Now let's alter something here. Let's change the name of the container from TF state to TF nope. Remember, that was another valid container that was created by the setup configuration, but it's not one that my service principal has access to. So I'm going to update that, and I'm going to undo the initialization by deleting the .terraform directory. Now that configuration is no longer initialized, so I'm going to try to initialize it again. And when I do that and it tries to initialize the backend, it's going to get a failure because it does not have access to that container, the TF nope. Okay, let's update this to be back to TF state and instead change the key to burrito wagon. So we're using the correct container, but we changed the key path a little bit. Let's try to initialize it now. Now it actually says that things were successful, but then we get a permissions error that says you actually don't have permissions on this path, even though I was able to access the container successfully. So if you do try to do a Terraform plan or apply, you'll get back a failure on this. And what you actually have to do in that case is delete the .terraform directory again and undo that change back to taco wagon and run another initialization, and now it will initialize properly. In this video, we have walked through a bunch of different decision points when it comes to using Azure Storage to store your Terraform state data. Some of those decision points are around permissions, correctly configuring those permissions at a few different levels. Next, we talked about authentication. There's a lot of authentication options that are available for the Azure Storage account, as well as connectivity. How are you going to connect to that Azure Storage account? Is it going to be over a public endpoint, or are you going to use private link? And then we got into encryption. There's a few different encryption options and different levels that might be required by your industry or some regulations. And then lastly, the durability and recoverability of your state data in case a mistake is made by your team or Microsoft has some downtime for a particular region. You want to be able to get to that state data regardless. Taking all those decision points into account and figuring out what your requirements are will help you narrow down the best configuration for you when it comes to using Azure Storage for your Terraform state data. That is going to do it for today's video. Thank you so much for watching. If you have more questions around configuring the Azure Storage account, Leave in the comments down below if you want to see a demo of how to deploy the private link endpoint or generate SAS tokens with the service principal. I could do that too. Just let me know what you would like to see in this realm of using an Azure storage account to store your Terraform state data. Until next time, keep calm and Terraform on. Bye. Well, that was totally unscripted and hopefully not a meandering mess, but I think I got the main points across. What do you think?